One Piece but real. Some physics behind the anime series One Piece. One Piece is an ongoing anime series drawn and written by Yuichiro Oda, which began in 1997. The story follows a pirate on a mission to find the mysterious treasure called One Piece. The One Piece world also consists of powers called Devil Fruits, where very little is known about their origin but grants the eater abilities. Some of these powers and abilities follow the laws of physics of the normal world, and some do not, such as the light fruit. The light devil fruit grants the user the ability to create, transform, and turn their bodies into light, essentially traveling, attacking, and defending at the speed of light. This brings us to the question, how does it feel to get hit by the speed of light? It is important to note that it is not possible to calculate the speed of a person being kicked with the speed of light. Therefore, we must say that the speed of the kick was traveling at 99% of the speed of light, which is about 0.99 c. From this clip, we can estimate the length of travel to be around 50 meters above the ground. Then we plug in our givens into the equation of Lm equals Ls square root 1 minus v squared over c squared, finding the ratio of Lm and Ls. We can use another equation, v equals bracket bracket Lm over Ls bracket squared minus 1 brackets multiplied by c over negative 1, which gives us a number of v equals 2.94 times 10 to the power of 8 meters per second. In the real world, anything that has mass cannot reach anywhere near the speed of light, as only massless particles like photons can travel that speed. For reference, a normal person can withstand no more than 9 g's of force for a couple of seconds, which is achieved by speeding up to 97.5 meters in 1 second, about 3 million times less than the speed of light. Therefore, we can say that the person being kicked in light speed would disintegrate immediately. Another physics connection I made with this anime is the gravity devil fruit. This fruit grants the ability to create gravitational forces which affect anything the user targets. One of the attacks that this power can conjure up is the meteor attack, where a meteor is pulled down from outer space and targets the opponent. The question then is, how much energy does the meteor hold? We can calculate the kinetic energy of the meteor by first finding the mass. From the clip, we know that the diameter of the meteor is around 2,400 meters and has a radius of 1,200 meters. We can use the formula volume equals 4 over 3 pi r cubed to get around 7.2 times 10 to the power of 9 cubic meters. Using the conversion rate of 1 cubic meter of concrete is equal to 2,406.53 kilograms, we get a mass of 1.74 times 10 to the power of 13 kilograms. We already know the speed of the meteor because when the attack is activated, we see that the meteor catches on fire. Therefore, we can estimate the speed of the meteor to be around 70,811.1 meters per second. From there, we can use the equation Ke equals 1 half mv squared, which gives us a total of 4.4 times 10 to the power of 22 joules of energy. The third and last connection I made with the show is the smooth fruit. This fruit grants the user the ability to become smooth. The user of this ability mainly uses it to defend against attacks, such as physical attacks or swords sliding off their skin. However, can this attack be useful in attacks? Or like offense? How much can the user accelerate when they slide off a ramp without friction? From the clip, we can guesstimate the angle of inclination to be around 35 degrees above the horizontal. Since we know her height and stature, we can also calculate her mass to be around 80 kilograms. First, we try finding for the forces along and perpendicular to the plane by using Fgx is equal to Fg sine theta to find the forces along the plane, and Fgy equals Fg cos theta to find the forces perpendicular to the plane. There are no forces acting perpendicular to the person, so we can use the equation F net x is equal to Fgx. We can also convert Fgx to mass times acceleration and just isolate for acceleration, which gives us the final equation of A is equal to Fgx over mass, which gives us an acceleration speed of 5.26 meters per second squared. Therefore, this fruit would be used for offense, as this gives the user above average speed. For reference, Usain Bolt, the fastest man to live, can accelerate 8 to 10 meters per second squared within a 100-meter dash. And our citations, yes. Bye. Thank you.